Let's talk today about literal equations. Now, what do we mean by literal equations? There's not necessarily a very scientific definition of them, but what we're really talking about are all these techniques of where we've got multiple variables floating around a problem. We want to actually keep it in terms of multiple variables, but we want to solve for just one of those variables. So we're no longer dealing with linear equations, but we're going to apply those linear equation techniques where we're basically going to pretend all the other variables in the problem are essentially numbers that we're just moving around, but they're numbers that we're not allowed to combine with each other because they're actually different terms. And then we're going to try to get that one thing that we want to solve for by itself. So we're still going to, really important here is don't want to just identify what the variable in problem is. We want to identify what the variable we want to isolate is, because there will be multiple variables floating around the problem, but we want to identify that one. Then we want to undo all the other operations using our typical inverse operation techniques that we've been using in regular linear equations. If there's a variable that appears more than once, we might want to combine like terms. We might have to kind of use our fraction or parentheses techniques, but really the techniques should feel very, very similar. And let's just illustrate. So there's a written illustration here of how we would solve for C in this case, where we would say, okay, we want to get C by itself, so we're going to add a to both sides, and then we're going to divide by S. We actually could take the same equation and solve for A instead. Why not? If we were going to solve for A instead, I would subtract SC from both sides, because now A would be what we want to get by itself, and let me label what I'm doing here. Solve for A instead. That would have negative 8a is equal to p minus sc. Then I would divide both sides by negative 8, and I would have my beautiful phrase for a. So you're essentially just manipulating the other variables. You're not paying too close attention to them, and then you're trying to get your one particular variable by itself. That's it. That's the kind of the steps. And there's another written example here about how to solve for b, if you find that interesting, which you can peruse on your own time. I want to kind of actually dive into some additional examples here. And there's one of them where we're sort of dealing with the same kind of equation. So you'll have a chance to sort of compare that technique. So let's say you had an equation for perimeter, and we wanted to solve for w. Well, what's going to be helpful is to highlight, okay, w is the variable I want. So I first have to undo addition subtraction so that I can get that w by itself. So I'm going to move everything that's not a w to the other side. In this case, I'm going to subtract 2l from both sides. I'll be left with p minus 2l is equal to 2w. And then as a final step, I'll want to divide both sides by 2. Alternatively, you could simplify this other side into p divided by 2 minus l by distributing that divided by 2 to both terms. That would be an optional simplification. This top one would also be considered simplified as well. W is equal to p minus 2l over 2. Go ahead and pause your video and see if you can solve the next two yourself. So the next two are actually basically the same steps. So in this first one, I want to solve for r, and the second one, I want to solve for m. So I'm going to highlight what I want to solve. So I'm going to divide both sides, in this case, by 2 pi. This is actually the equation for circumference, by the way, of a circle. And I'm left with radius is equal to c over 2 pi, and that would just be my final answer. Similarly, for f equals ma, I want to get m by itself. He's currently being multiplied by a, so I'm going to divide both sides by a, and I get f over a is equal to m. For this last one, if I want to solve for x, there's a couple different ways I can go about doing it. What I would actually recommend doing is undo what's going on the outside parentheses with actually good old-fashioned division. You could technically distribute it in, but I would actually caution against it. And what do I mean? Well, just maybe even one term at a time. First thing I'm going to do, divide both sides by h to get rid of that multiplying by h. Then I'm left with a over h is equal to 1/2 b plus x. Then as a next step, what I'm going to undo is this multiplying 1/2 by multiplying both sides by 2 over 1. That cancels out to make 1. I really have divided both sides by 1/2. And I'm left with 2a over h is equal to b plus x. And that's nice because now my only step left is to undo the addition subtraction by subtracting b on both sides. So I'm left with 2a over h minus b is equal to x, and I have just solved that literal equation.